Hello guys, in this experiment we are going to know about 555 timer IC and its applications. Before going into experiment we need to know what an integrated circuit is, or shortly an IC. An IC is a collection of electronic components like resistors, transistors, capacitors, etc. All are integrated into a tiny chip made of silicon and connected together to achieve a common goal. This is the internal structure of an integrated circuit. As of today, typically, chip areas ranges from a square millimeter to around 600 millimeter square, which up to 25 million transistor per millimeter square, which is a size of human hair. Among these ICs, there is one which is old and widely used, so-called 555 timer IC. This is the internal structure of a 555 timer IC, consisting of two comparators. This is the first comparator and this is the second comparator, and a flip-flop, and output driver and 3 5 kilo ohm resistors. This is the internal structure of 555 timer IC, consisting of 25 transistors, 2 diodes and 15 resistors inside a single chip. Let us discuss the generalized block diagram of 555 timer IC. Here is the 555 timer IC generalized block diagram. Pin 1 is ground, pin 2 is the trigger pin, pin 3 is the output pin, pin 4 is the reset pin, pin 5 is the control voltage, pin 6 is the threshold pin 7 is discharge pin, and pin 8 is VCC. Pin 1 and 8 are connected with 3 5 kilo ohm resistors, which gives this iconic IC the name 555 timer IC. It also creates two potentials, 2/3 and 1/3 of VCC. Pin 2 is the trigger pin, which directly connects to the negative input of the first comparator. The positive input is connected to 1/3 of VCC. The output of the first comparator is connected to set pin of RS flip-flop, and the output of the flip-flop is connected to the output driver, which in turn connected to the output pin. The reset pin of the 555 timer IC connected to the reset pin of the flip-flop. The control voltage is directly connected to 2/3 of VCC, and threshold pin is connected to the positive pin of the second comparator, and the discharge pin is connected to collector of BJT, bipolar junction transistor, and the emitter is connected to ground. The base is connected to the output driver. This is the internal structure of a 555 timer IC. The first comparator in the internal structure is this. And the second comparator is this. And 3 5 kilo ohm resistors are those. And flip-flop and output driver and a BJT. We can discuss internal structure later. Coming to the applications, 555 timer IC worked in 3 modes: bistable mode, monostable mode, and in a stable mode. And the next thing we need to know about a comparator. What is a comparator? A comparator consists of 2 inputs and a single output. Of these 2 inputs, one is inverting pin and another is non-inverting pin. The positive pin is the non-inverting pin and the negative pin is the inverting pin. If the positive pin voltage across the positive pin is greater than voltage across the negative pin, it outputs binary value of value 1, and if the voltage across the negative input is greater than voltage across the positive input, it outputs 0. This is the basic principle of a comparator. Coming to the flip-flop, it consists of 2 inputs, set and reset, and an output Q dash. If S is 1 and R is 0, Q dash is 0. If S is 0, R is 0, Q dash is 0, and if S is 0 and R is 1, Q dash is 1. Now let us discuss the working of 555 timer IC in a stable mode. Now in a stable mode, the extra components added to the circuit is 2 resistors and one capacitor. These 2 resistors and capacitor are connected in between VCC and ground. Now in a stable mode, the threshold pin is connected in between the resistor and capacitor, and the trigger pin is also connected in between the resistor and capacitor. Now initially the voltage source tries to charge the capacitor through the resistors R1 and R2. Now until the capacitor reaches 1/3 of the VCC, negative input of the first comparator is less than the positive input of the first comparator, which is 1/3 of VCC. So it outputs 1. Vice versa, the second comparator outputs 0. So the output of the flip-flop Q dash is 0, which gives a output of high, that means 1. Now when the capacitor charges 1/3 of VCC, the negative input of the first comparator is greater than positive input of the first comparator, which outputs 0. As a result, the output of flip-flop Q dash is 0 and the output driver is high. Now when the capacitor charges to 2/3 of greater than 2/3 of VCC, the output of the first comparator is still 0. Since the negative input is greater than positive, the output of the second comparator is changed to 1 since the positive input is greater than negative input. So output of the Q dash is 1, which in turn connects to emitter base of the BJT and connects to ground. As a result, the output of the 555 timer IC pulled low. Now the capacitor tries to discharge and the output still remains 0. Now again the cycle repeats when the capacitor charging and the discharges. As a result, it gives a square wave at the output of the 555 timer IC, that is pin 3. This is the working of 555 timer IC in a stable mode. Thank you. In the coming videos, we will discuss about monostable and bistable.